This is Brian Putt. Today I'd like to talk to you about modeling with Metalogs. This is a new distribution that's been added to the SIPMath toolbar, and it generates distributions based on various parameters. It generates closed forms equations for both the probability density function, the PDF, and for the cumulative distribution function, the CDF, given just the P10, 50, 90 values. You can also specify lower bounds, P0, and upper bounds, P100, for the distribution. So unlike the normal, or in some cases the Meyerson distribution, they can have very, very high limits. And this is a way of bounding the distribution. If you put in inputs that are not mathematically correct, the Metalog will give you a message and tell you acceptable values. Unlike a lot of the other parameters, other random variables in SIPMath, this particular random variable requires a template, and that template is loaded by SIPMath. The templates can be copied or moved. The Metalog template can be formatted in several different ways. First of all, they can have a vertical format with and without graphs, and a horizontal with and without graphs. The number of rows required and the columns required is shown in the table. You can see that if you ask for graphs, it adds considerably more rows to the template. However, if you do not have graphs, you can still get graphs by defining that random variable as a SIPMath output variable, and then graph it using SIPMath as a histogram or as a CDF. We can see the SIPMath graphs over here, cumulative distribution function and histogram, and compare that to the Metalog graphs of a CDF and a PDF, which is a continuous function. So what do these template formats look like? The vertical format is shown here on the right. So here, this 27 in this little histogram is where the random variable is located. The inputs, the quantiles, are shown here for low, mid, and high. And as I mentioned previously, you can also specify a lower bound or an upper bound. And you do that by changing this variable here from an unbounded to a lower bound to an upper bound to be bounded on both sides. The horizontal format looks like this, very similar, except the input data is horizontal. In either case, if you ask for multiple random variables, templates are pasted to the right. So for example, if I had multiple verticals, I'd have a template here, and then I'd have more templates going off here to the right. And if I had horizontals, I'd have more templates going off here to the right. So what's a good modeling practice with Metalogs? Well, there's no right or wrong way. It depends on the number of Metalogs and the purpose for using those Metalogs. If you have just a few random variables, the inputs can be entered directly into the templates with or without graphics in the model. Not a problem. Just make sure you have enough room in your model for the Metalog template. However, if you have many random variables that are going to be Metalogs, probably the best practice is to put them into a model, put the inputs into a modeling worksheet, and then put the Metalog templates on a separate worksheet. We can then link the input values to the templates using an index command, and then we can bring back the random variable results also using an index command. We will show the example using 10 Metalogs in the next video. For more information about Metalogs, please visit metalogdistributions.com.